Section P.6 is titled Complex Numbers. In this section we're going to briefly just go over what a complex number is, but very brief. We're not going to go into depth too much, as we're going to save a lot of the depth of complex numbers to the trigonometry course. But then we're going to go over just kind of operations that we can do with these complex numbers. We're going to add, subtract, multiply, divide them, and then allow them to become solutions to equations that possibly right now we would classify as not having a solution. So by introducing this new set of complex numbers, we'll be able to solve more equations. Before we get to complex numbers, we have to first develop an imaginary number. We need a number that has the property such that when you square it, it comes out to be negative. So to be as simple as we can, let's pick a number such that when we square it, it's just simply -1. Instead of -2 or 3 or 4 or anything like that, let's just pick -1. And since we don't have a number that does that, we just kind of make one up. We imagine one. And so we just use the number or the letter I to represent this imaginary number. So this new number I has the property that when I square it, it becomes -1. Therefore, if I take the square root of both sides, we get I is the square root of -1. So there's our imaginary unit, or our imaginary number. I is equal to the square root of -1. Now, the set of complex numbers then are ones that are made up of both real and imaginary numbers. So let's write that out. Complex numbers are made up of real and, say, imaginary numbers. Okay, they are of this form. Typically, a lot of texts use the letter Z to represent or denote a complex number as being used, but they're of the form A plus BI, where A is the real part and the BI is the imaginary part. And like I said at the outset to introduce the lesson, we're going to spend a lot more time with these complex numbers in the trigonometry course, almost a whole unit on complex numbers through the lens of trigonometry. But in this particular section, in this course, we're just going to go over operations. How can we work with these complex numbers? And then what do solutions to equations look like that have these types of numbers as their answers? To begin, we'll look at adding and subtracting complex numbers. Now, when adding and subtracting complex numbers, it's just as simple as adding and subtracting like terms. The complex number I, or the letter I, can be treated like any other variable. You can treat it like x's if you prefer. When I add these complex numbers, I add the real parts. 7 plus 5 is 12. I add the imaginary parts. 7i plus 2i is 9i, and that's done. In the second example, it's a subtraction example, but it's really no harder than the addition example. I identify the like terms, and I'm going to combine the like terms. 18 minus 1, 17, -3i minus -9. The minus negative here becomes plus, so I really have -3i plus 9i. It's going to be plus 6i. When I multiply complex numbers, it's simply an exercise in distributive property. You can think like you're foiling. Again, the i's are just variables. You treat them like they're any other variable. If I were to FOIL this, I'm going to follow the products along these lines. I get 6 plus 15i minus 8i minus 20i squared. If I combine my like terms, we have 6 plus 7i minus 20i squared. Now go back to a couple slides ago when we introduced this imaginary number. We had the property that I squared is equal to a negative 1. Okay, we're going to use that now. I'm going to replace the I squared with negative 1. So then it becomes 6 plus 7i. So this really is negative 20 times negative 1. So two negatives become positive 20. So I then have, there's my 7i, my like terms here are 26. Let's put it in front. 26 plus 7i. Second example, 4 plus I quantity squared. We'd be best served writing it out first. 4 plus I times 4 plus I. If you like to draw the lines, these are the paths I'm going to multiply on. 4 times 4 is 16, plus 4 times I is 4i, plus I times 4 is 4i, plus I times I is I squared. So we have 16 plus, these 4 i's become 8i, this I squared becomes a negative 1. So the 16 and the negative 1 become 15 plus 8i. When we divide by complex numbers, since i's are really square roots, they're square roots of negative 1s, dividing by i's is like dividing by square roots, and so we follow our rules for simplifying expressions that are dividing by square roots, and that involves rationalizing the denominator. If I were to rationalize this, I multiply top and bottom by 2 minus I. Okay, so the numerator becomes 6 minus 3i. The denominator we're going to FOIL becomes 4 minus 2i plus 2i minus I squared. What should happen is that these i's in the middle cancel out. Negative 2, positive 2 cancel out. They add to 0. So I've got now 6 minus 3i divided by, let's remember that this I squared, just change color here, this I squared is a negative 1. So we have a minus negative 1. That's really like a plus 1 right there. So I have this 4 plus 1. The denominator is 5. Typically we like to see the fractions split up. So 6/5 minus 3/5 I. The reason why I would split that fraction up into two separate fractions is it might be possible sometimes to reduce one and not the other, and if that's possible I'd want to do that. In this case they both don't reduce, but I still prefer to see it like this. In the next example, start the same way. We're going to rationalize the denominator, so I multiply top and bottom by 1 minus 2i. In the numerator I have to FOIL, and the denominator I have to FOIL. So let's see, I'm going to go a little quicker. You can pause it if you need to slow down. I'm not going to draw the lines either, but we get 3 minus 6i minus 2i plus 4i squared. Denominator is 1 minus 2i plus 2i minus 4i squared. Okay, the like terms, let's identify them. These are going to add, these are going to cancel, actually. The I squareds are going to be negative 1s. So we end up with, see, this is really a negative 4. So the 3 and the negative 4 are negative 1. Minus the i's add to 8. Divided by, here the i's cancel, so it's just 1. And then these become positive 4. 1 plus 4 is 5. Split it up, we have negative 1/4 fifth minus 8 fifths I.